Hey, Alvinos,
All right, is everybody on now?
yeah.
Okay. Okay, so let's get back.
Yes.
Everybody on? Good. So as I was saying that I leave this piece here with you to think. In my view, if I'm going out to paint for my shop floor, obviously it's not the floor alone. I think you have to paint the walls. When the Americans are talking about a shop floor, they're talking about the space you have for your shop. So in that case, you have to find the area of the floor, which we did here. But then you also have the area of 3 walls, right? One would be 20, the width, the long side, 20 by 8 high. Then the length that they give you, 17.41 by 8 high. And then you have the short side, what I call on the width, 5 feet by 8 feet. So you have to find out all of that. Find these areas, add them, and also, if you're painting the floor in the same color, you add to the area that we found for the trapezoidal. So I leave that with you to ponder and to think, and I think the problem was God sent in terms of the material that we need to cover. Okay? So what I'm showing you new here is the area of a trapezoidal, or a trapezoid, or a trapezoidal figure, which is a half, well, the sum of the parallel sides, as we see, which is another way of saying the average of the parallel sides, because 1 a plus b divided by 2, because the number is 2, by the length, the distance between them, in this case is the length, and perpendicular distance that is there all the time. All right, so if we don't have any doubts, I want to press on. We lose some time, but we have to pick it up, so bear with me. Geometric shapes, and are following strictly from the book that was given to you, that you downloaded, and it's there. We're talking areas. First of all, the most important, we have to calculate the areas first. As I say, is the first step in working on these geometric shapes. And specifically, we're dealing with the circle, the rectangle, the trapezium. All right? The trapezoidal structure, or the trapezoid. All right? And they say that these are the most common that you'll find in the water industry, and that is true. But at times we will meet the sphere. So we have the spheres on the syllabus, the triangle, the half circle with a rectangle can also be found. Okay? So let's move on. So I cut it out there, it's there for you. The area of a circle, 0.785, the diameter to be squared. We have that, and you'll get that in your sheets. You'll get that in your formula sheet to start. This is a rectangle here, and this is a trapezoidal or trapezoid. Again, you have two sides parallel, B1 and B2. In this case, the perpendicular height is from here to here, and it's in the middle here. That will have to be given if you have to work a problem. Again, same, it's a half the sum of the parallel sides. Okay, so you know the sum of the parallel sides divided by 2, and then you multiply by the perpendicular height or the depth or whatever they will give you. And then you might get a combination where you have a half circle. So the area of a circle is 0.785 d squared and divided by 2, give you this area. You'll have to find it in pieces.
Yes.
And then the area of the rectangular part would be L by W. So the area of this whole thing is that formula you're seeing here. A sphere, the area of a sphere is 4 times that of a circle. Yeah? And then, importantly, if they ask you to find the area around a cylinder, and it's different to what you call the total surface area, the area around the cylinder, just think about the cylinder, you cut it down here, where you see these dotted lines, and you open it out. So obviously, you have the height here, which is one side, is like a rectangle now, but when you cut down this side and you open it out, you open it around, you're cutting open what you call the circumference of the circle, and you're spreading that out. And the circumference of the circle is 2 pi r or pi d. Pi by the diameter, by the height, will give you the area, what you call the area around a cylinder. So bear that in mind, you have it there. And just to reinforce the one with the area of around the cylinder, and I want to compare it with a total surface area, because that will come up. Again, the area around the cylinder will be around the cylinder will be the area around the periphery here. And think about it, if you cut it down and you spread it open, that's this area. Okay? So as it says, pi by the diameter. In this case, pi is, remember, pi is 3.14. And the diameter. And then the height is the other piece. Right? So pi d by h will give you the area around. Now, I want to add in that they could ask you to find the total surface area if you have to. Don't confuse it with the area around the cylinder. The total surface area would be that distance around the cylinder, which we just spoke about, plus you have 2 covers. Look at the 2 ends. He's sitting on one, and he's sitting on another one. He's sitting on one and one at the top. So basically, you have the area of 2 circles there. So it's twice times the area of a circle, which is 0.785 d to be squared. So bear that in mind. And there is a difference. One entails the other. One is the composite of the other. The total surface area is the distance around the circle plus the area of, around the cylinder plus twice the area of the circle and at the end of the bottom. You have one here and one below. All right. Any doubts on that? That is also in the book that you downloaded without a problem. But as I said, I add the total surface area to it. And reinforcing the trapezoidals, and so you might, the trapezoids. You'll ask yourself why this trapezoids? Remember the exams are US based. EBC is US based. And the aqueducts that carry water from one district to the next, a lot of them are made of concrete. And they travel miles and miles and miles, and some of them, and don't argue, but we found out with this kind of an open channel flow of water, the trapezoidal shape is much more efficient, right? And hydraulically, you could prove that, right? But that is beyond the scope of that. So you have these aqueducts to transmit water, and the cross-sectional area, so to speak, is trapezoidal, all right? And as I said, it has a flat, narrow bottom, and then it slopes towards the top as it gets wider as it rises to the top. So the top ends up being wider, so to speak, than the bottom. Bear in mind, the top width and the bottom width will be parallel. That makes it a trapezoidal. The important information you need to know is the distance, the perpendicular distance between these two. In this case, it's a trapezoidal figure to carry water. So the depth, h, from the top to the bottom, is what is your distance between the 2 parallel sides. Okay? So if you're going to find it, you have to add B1 and B2. Right? In this case, for example, you have 5 or 7, and you divide that by 2 because the average of the width you're really finding. So it's a half Some of us like to say it in the days of primary school, half the sum of the parallel sides. The sum of the parallel sides, 5 and 7 in this case, if in this example, B1, B2, divided by 2. And then the height, in this case, H by 6 will give us 36 square feet. Okay? If we're clear on that, we can move on. Any doubts, we could take it now. Then you have to go to the volumes. Again, this is a page I cut out from the manual. Everybody have it. Once you download it, you could get in there. And it's trying to illustrate moving from what you call a two-dimensional figure up to 3, and so on. Or even a single dimension, a plane, what we call a planar figure, to a double dimension, which is a 2-dimension, to a triple dimension. So for example, with the circle here, you know the area of a circle? From the circle, you'll have evolving a cylinder when they include the height. So basically, it's the area of a circle by the height will give us a cylinder, right? 0.785, the diameter to be squared by the height of that cylinder. If it's a tank in the ground, it will be the depth. The height H here will be whatever depth that we get, and so on. And look at it from this point of view. In our pipes, we've been bringing it closer to home, right? We'll have the circle here, a circular pipe, and we talk about a length of pipe. So based on this length of pipe here, we realize a cylinder is being formed. So we could calculate the volume of water and X distance away. There's a circular pipe, and then we're talking about a length, right? So we're talking about a volume 0.785, the diameter to the squared by the length. Likewise, the rectangle to end up with a rectangleizer, right? Imagine you have a tank in this form of a rectangle. The area, so to speak, is a rectangle. The length by the breadth is the area, the length by the width. And then if you give it a length, like a trough, length by the width, right? By the height or the depth would give you that area of that rectangular. It would be a tank or so. And there they stick in the trapezoidal figure again. You have the area being that 2 parallel sides. So the area is half the sum of the parallel sides, B1 plus B2, right? Or B1 plus B2 divided by 2 by the height between them, and the height must be the perpendicular height, not any old height, not this height, not this slant height, not this slant height, but the perpendicular height from top to bottom. And when you put a length on that, you get a trough. Many treatment plants and the same aqueduct we're talking about, for example, you put a length on it and you end up with a figure looking like that. So the volume here would be the area, which is I have the sum of the parallel sides multiplied by the height of the perpendicular height between them, and in this case multiplied by a length across would give you the volume of water in this figure. And the sphere, right? You have the area of a sphere, right? And then you get the volume. And the volume is pi d cube. Look at the difference. The area is 4 times the area of a circle. That's the area of a sphere. And when you come to the volume of a sphere, well, pi, as you know, is 3.14. So 3.14 by the diameter to be cube divided by 6 give us the volume of a sphere. So if you had a tank in the form, and many in North America, some of the standpipes are like that, the tank in the form of a sphere, a ball, you could go ahead and find the volume. Pi by the diameter to be cube, 1/6 of that, divided by 6. Clear now, that is there. That is not for you to remember by heart. Some of the formulas I give you when you're going into the exam, and you could get it, as I say, you download it and practice. So without further ado, I want to go into a few questions, and I want us to structure the questions, and I want to use some of the formulas as it is, as it's done, as it should be done, as it's done in engineering, and as it's done in the exam. Illustrative example. If a pump discharges 27,239 gallons in 2.5 hours, what is the flow rate in gallons per minute or GPM. Again, your setup, you known and you unknown. You know the volume. The volume is 27,239 gallons. And the time it take to discharge that volume is 2.5 hours. I want us to remember that you know that 1 hour is 60 minutes. All right? And they ask you for the flow rate, so your flow rate is what is unknown. I like to call that Q because if you're working maths, you could, that's a standard symbol for the flow rate. The formula I want to introduce to you, I mean, you will be doing it just by head and by common sense, but let's put some structure into it. The flow rate is always equal to the volume divided by time. So the flow rate, for example, gallons a minute, is a volume in a time. So flow rate is equal to volume divided by time. Q is equal to V over T. I call it V, big V volume, and T in time. T is time. All right, so in our case, Q, as I say, is the flow rate which was asked us. Q would be, what is the volume? 27,239 gallons, right? Divided by what time? 2.5 hours. But I know that 1 hour equals 60 minutes. So if we could bring 2.5 hours straight away because we want to go to minutes, gallons per minute, 2.5 hours multiplied by 60 minutes per hour. And the hours will go, they will cancel out. So I end up with gallons on top, right? And obviously minutes below. 2.5 by 60 is 150. 239 gallons divided by 150 minutes, it was 181.5 gallons per minute, or GPM. Everybody clear on that? So stay with that formula. You will see it and many other formulas as you go forward in the course and as you go to level 1 and level 2. The flow rate is always equal to the volume divided by time. If you don't have any doubts, I could press on. Example 2. Illustrative example 2. A hypochlorite solution is being pumped from your day tank that has a diameter of 3 feet. Remember I said to you that the true name for mathematics is mathematical analysis. It helps you analyze. All right? It helps you analyze and you're supposed to be thinking. One time when I see diameter, I'm thinking about something circular. Okay, you're talking about diameter. You're talking about a tank and it has a diameter of 3 feet. One time I'm thinking the tank is a cylindrical tank. So you see, you have to think, right? Because the cross-sectional area, once you get a diameter, the cross-sectional area will be a circle. And the fact that it's a tank that could hold water, it must be a cylinder. All right? The level of the tank drops 1.75 feet in 4 hours. And he asked us how much gallons per minute of solution were used. So you have a hypochlorite solution in mixing to chlorinate your water. You have a little D tank there, 3 feet in diameter. And when you check the levels, you realize that you're dropping 1.7 feet in 4 hours. So obviously you could find how much solution you use in that time. So separate the knowns from the unknowns. I know the diameter of the tank, which is 3 feet. I want to remind you that 1 hour is 60 minutes. Off the bat, put it on one time. We have a height, right? That's the level of the water after 4 hours. We have that. It was 1.7, it dropped 1.75 feet, okay? And obviously the shape again, I explained that. Tells me diameter, it leads you to think that it's a cylinder. The tank is cylindrical. So one time I go into formulas that come to mind is the volume of a cylinder, which is 0.785, the diameter to be squared by the height, right? Because a tank in this case, H, which is a pipe that is horizontal, you say L. And remember the volume of, and that would be a volume of water that you dropped in 4 hours. Remember that, I'm putting that in brackets so that you'll bear that in mind. That's the volume that, not of water, no, but of chloride solution. So 0.785 by 3 feet, 3 squared by 1.75. If you use a calculator, which I think you're allowed to do, you should get 12.36 cubic feet, because you have feet to be squared here. By multiply by feet, you must get cubic feet or feet to be cubed as your answer. All right? But remember, they ask you for gallons per minute. I get a volume in cubic feet. So I have to remember that 1 cubic foot is 7.48 gallons. Remember, when we're talking gallons, we're talking about the US. That's the only people that keep that. So it's US gallons. It goes without saying. So 1 cubic foot is 7.48 gallons. So what will be your volume? Your volume of water dropped down in 4 hours. 12.36 cubic feet multiplied by 7.48 gallons per cubic foot. 1 cubic foot is 7.48 gallons. So if you want to bring your cubic feet to gallons, everybody should know that by now. In our case, it's 12.36 cubic feet by 7.48 gallons per every cubic foot. And the cubic feet will go with the cubic feet. And always do that. Your dimension analysis, the maths book that you download there, start off with that. So important. You compare and you work apples with apples, and not apples and chalk, and not apples and oranges. And you do your dimension analysis, and when you cancel out and see how things go, if you, at the end of the day with your dimension analysis, if you can't get what you're looking for, then you know you made an error. So 12.36 cubic feet by 7.48 gallons per cubic foot, the cubic feet will go with the cubic feet. And you end up with 92.48 gallons. And what time are we talking about? 4 hours. All right? And if you bring hours to minutes, 4 by 60. So in 240 minutes. And remember, the flow rate is your volume, right? Divided by your time. So it's spit out 92.48 gallons in 240 minutes. So we're talking 0.385 gallons a minute. I hope you're using your calculator there, so you coincide with me. Okay, any doubts on that? The formula I want to stick in your head today is that flow rate is always a volume divided by time. So when you see gallons a minute, it's a flow rate we're talking about. Yeah? Million gallons per day is a flow rate we're talking about. And it's always a volume divided by time. Any doubts? If you don't have no doubts, you could press on and try and pull it back on time. And I want to, this one is what I call the hallmark for today, the pinnacle. Because we combine nearly all the formulas together, all what we did so far. Again, this didn't come from the air, they are in the book that you downloaded, the maths book that you downloaded off from the platform. I could go ahead. Any doubts? Anything bugging you? Silent means consent, so I will press on. A contractor just installed 350 feet of 8-inch diameter pipe. He also installed 430 feet of 12-inch diameter pipe. And he also did 275 feet of 6-inch diameter pipe. And these pipes need to be filled. But the flow rate is only 10 gallons a minute. How long would it take to fill all this pipe? And give your answer in the best time format. Give your answer in the best time format. Remember again, that's common sense. And start thinking, right? And when you start thinking, if your supervisor call you and tell you how long you took, don't call him and tell him you take 1,000 and something minutes. He can't interpret that. You know you have to bring minutes to hours and hours to days for it to make sense. So when you talk about the best time format, that is, in my view, what they're referring to. It sets you thinking from the beginning. All right? What jumps out to you one time? I see pipe in feet and I see 8-inch diameter pipe. I see 12-inch pipe and I see 16-inch pipe. Without a doubt, these pipes are circular. These pipes are circular. So 350 feet of that circular pipe would form a cylinder line on or in the ground, right? So we're talking, we putting in and we're impinging the common sense, the practical common sense into the maths. So once you see that, you know where you're heading. Again, I give him a flow rate 10 gallons a minute. So let's see what we problem say. Again, we're starting off with the known and the unknown. Don't mind my lines and my arrows you see. You will see why I put them there. I divide up my screen like that. In terms of known, the first thing I know is length number 1, which is the length of the 8-inch pipe. And I put in red the fact that I see 8-inch pipe. I want to put in red one time again. One, remind me, you talk about a diameter, so you're talking cylindrical, right? Let me give a time and a volume. So that's me unknown to start. Let me see what else I know. I have a second length, length number 2. And I call it L1 and L2 to make life easy for you when you're coming down to calculate your answer. You don't want to rewrite the whole word length and rewrite the whole word diameter again and so on. That's why we use symbols. And I want to also remind you that a foot is 12 inches. Because I'm talking about feet of pipe, 430, 200, 350, and 430 feet of pipe. But yet for all, I'm quoting the diameter of the pipe in inches. So bear that in mind one time. And remember to work, I have to have unison in the units. The dimensional analysis must make sense. Apples must compare with apples. Feet with feet, inches with inches when you're working out. And you have to convert one to the other before you calculate. I also have length number 3. It says he did 275 feet of a 16-inch diameter pipe. So, as I told you just now, let's bring this 8-inch pipe, 12-inch pipe, and 16-inch pipe in terms of feet one time before we proceed. D1 will be 8 inch over 12 inches. Remember 12 inches in a foot, 0.667 foot. Diameter 2, that's the diameter of the length of pipe 2, which is 12 inch. 12 divided by 12, that's 1 foot. And number 3, a 16-inch pipe would be 16 divided by 12, which is 1.33 feet. So with that now, you're setting up yourself where you could use your calculator and you won't end up in trouble. Remember, they give you the flow rate. The flow rate was equal to 10 gallons a minute. Remember the formula for the flow rate? The flow rate is the volume divided by time. Q is equal to the volume. Q is equal to V over T. Remember that and you wouldn't go wrong. So look at it here. If the flow rate is equal to the volume divided by the time, remember flow rate. 1 is always 1 over 1. We don't put it. 2 is 2 over 1. X is X over 1. So flow rate by itself is really flow rate over 1. And that is equal to the volume over time. And I'm doing that because I want to cross multiply because they asked me for a time. If flow rate over 1 is equal to the volume by the time, and you remember how you cross multiply 1 by the volume equal to time by the flow rate, or time multiplied by the flow rate is equal to the volume by 1. And volume by 1 give you volume. Everybody happy? Time by the flow rate is equal to volume. So my time would be the volume divided by the flow rate. And I want you to work with the formula so you don't have to guess and think, well, it's so, whether it's multiply, whether it's divide. Work with the formula. So what I really want to leave you today is putting a little structure into what you do using the formulas to calculate these questions. So I could get the time divided is the volume divided by the flow rate. But volume itself, we didn't give us volumes. They give us lengths and they give us diameters. And remember your formula again, your volume is, I call it V again, 0.758, the diameter to the square, which is the area of a circle, by the height or by the length. In our case, it's the length because we're talking about a pipe, which was, we think, common sense tells us laid horizontally. So I'm talking about L. Same thing. All right? So look at your volumes. And I call it volume 1. Volume 1 would be the volume of the 358-inch pipe, 0.758 by the diameter to be squared. Look, I calculated what the 8-inch pipe is already to be squared or to the power of 2 by a length of 350 feet. That gives us 122.23 cubic feet. And likewise, volume 2 and volume 3 with those data that we have. All right? And I get a total volume when I add them up. Because remember, you want to fill all these pipes with a little 10 gallons a minute of water. And you really want to know how long it will take. So the total volume is 843.56 cubic feet. And remember, a cubic foot again, 1 cu.ft is the same as 1 cubic foot, and that is 7.48 gallons. So my total volume then is 843.56 cubic feet multiplied by 7.48 gallons per cubic foot. Watch it, and that per means to divide. All right? Remember that, you can't go wrong with that. And then the cubic feet, we'll go with the cubic feet here. And we end up with 6,309.83 gallons of water that he needs to fill all these 3 pipes together. Again, going back from here, I had it already. My time is volume divided by flow rate. I had a total volume of 6,309.83 gallons, and my flow rate was 10 gallons per minute. And I'm taking out the P for the per, and I put in the backslash or the front slash so that you remember that means to divide. That's what per is. All right, so I ended up with a time of 630.98 minutes. But you have 1 hour is 60 minutes. 60 minutes an hour. Therefore, the time is 10.52 hours. Yeah? Which is, rounding up, is 10.5 hours. I think it's a decent way in terms of time format. Remember at the beginning, they asked us to put it in a reasonable time format so you could report. Somebody would understand. It makes sense. If you call the office and you say, hey, you know, it took me 630 minutes, you're telling a supervisor that to fill that, he had to take out the calculator and collect it. It's different to do it if you tell him that it took 10.5 hours to fill all 3 pipes. Yeah? So that's what it is. I think that one was a classic. That one is in the book there again, and I take my time and give you that one. We're uploading the PowerPoint presentation. We're uploading the PowerPoint presentation as soon as you finish the class so you could follow the formula and the steps. Any doubts? All right. So we have this one last slide with some problems, all right, of flow and rate of flow and so on again. Somewhat straightforward. I wanted to use the whiteboard, but it's applying the same formula that we use. And the first one was water flows through an aqueduct of a velocity of 0.55 feet per second. How many miles will the water travel in 1 day? Interesting. Imagine you're going 0.55 feet every second. Yeah? And they want to know how many miles you travel in 1 day. So the crux of the matter, you have a flow rate, sorry, you have a velocity in this case, not flow. And then you know you're talking about in a day, you have a time, 1 day. So what makes sense there is to bring your velocity, take 1 day and bring it in terms of seconds. So 1 day, 60 seconds in 1 minute, multiplied by 60 minutes an hour, multiplied by 24 hours per day, will take you from seconds, will give you how much seconds in 1 day. And then you multiply that by 0.55, and you will get how many feet you will travel in a day. And we have to remember one thing, for those of us who don't remember it. When I was going to school, we used to remember it by heart. A mile, everybody remember what is a mile in terms of feet? A mile is 5280 feet. 1 mile is 5280 feet. So that answer that we get in feet, if you divide it by 5280, you will know how much miles you will travel in one day. Yeah? We have time to go to the whiteboard, or we need to go to the whiteboard for that? Tell me. Engage me now. I've been talking all morning. Somebody engaging me? I guess nobody hearing me. Shall we log out already? Are we there? Hello?
We there.
All right.
Everybody's there.
I was asking them if they want me to go to the whiteboard to work that out. And that was the plan. I mean, we lose some time.
Yeah, well, I think you should, any bit that helps with math, I think it's always good.
Yeah. So I will have to go. I have to change the computer. That will take me a minute or two because I have a touch screen laptop here, which you'll be able to mark. So that's the last time. It's just 3 problems I have. 4 problems, that is. Some are very straightforward. This one here with the faucet is a little involving, it's just to make you think. Yeah. A faucet dripping at a rate of 3 drops per second. How many gallons would leak the faucet? The faucet will leak in 30 days. And they told you, assume that 18 drops is equal to 1 ounce. What I want you to do for me while I'm setting up there, just go. Some of you all have your smartphone, just log in. First of all, find out how much feet in a mile again, and remember that, mark that down, it's 5280. 1 mile is 5280 feet. Also log in, well, we know how much hours in a day. We know what is a million, 1 by 10 to the 6. But the next thing you could go find out is how much ounces make a gallon. You could log that in and get it. And that's what it is. While I set up the board here, we will take our last 10 minutes and just run through this simple question. So you could find those things for me there while I set up and log in. I'll have to log out from this platform and come back because I'm going to a different computer. I hope you won't disrupt anything. I'm just going out to come back. You unmute your mic.
I guess you just have to log back in.
Right, that shouldn't be a problem. I'm about to do that.
Okay, we'll hang on. We'll wait for you.
Yeah.
All right.
Okay.
All right. Yeah, just bear with him a bit. He's logging out to come back on.
Makes sense with the
Right.
It makes sense with the
back
screen.
on.
The mark on the screen. Meantime, do my homework for me while my computer coming up. You had it up, but when you have screensaver, it always will go off and come back.
When you making happy yourself? Please.
Great. I think I'm on. Everybody hearing me? Ja, you hearing me? All right. Okay. Okay. Somebody confirm that they're hearing me, and then let's move on.
Yes, we can hear you loud and clear.
Right. Sounds good. Okay. So we're going back to the first problem again. Okay. You had it. I dropped out, so I guess you could write, and you will get it. It said water flows through an aqueduct at a velocity of 0.55 feet per second.
And look at that symbol. So you have a, remember the aqueduct is like a pipeline. It could be trapezoidal. And we talk about a velocity of 0.55 feet per second. Okay? And I want to know how many miles the water will travel in 1 day. All right? So in 1 day, what we have in 1 day? To start off, we're looking at seconds. We need to bring a day for we to be able to work again. I said the units, we have to get unison, right? You can't be here, there, and every day. You could be there if they state the problem, but then before you calculate, you bring it in one. So I'm bringing day to seconds. And we know we have what, 60 seconds? Per minute? $60 seconds per minute. And we have what? 60 minutes per hour. And we have what? 24 hours in a day. 24 hours in a day. So hours would go with hours, right? Hours would go with hours. Minutes would go out with minutes. Right? And the seconds going out to who? Remember we had to multiply all of that by? We had to multiply all of this, what we're getting here by, to change velocity, for example, would be 0.55 feet